You know the scene, right? Deep beneath the streets of 19th century Paris, Jean Valjean is in a desperate escape, carrying an unconscious Marius on his back. The air is thick, the darkness is absolute, and every single step is a monumental battle. It is, without a doubt, one of the most powerful sequences in all of literature. But what if there's more going on here than just powerful drama? What if this whole epic struggle is also a physics problem?
I mean, really think about it. What if Victor Hugo, when he was writing this masterpiece, wasn't just a novelist? What if he was also, without even knowing it, an engineer, building a world so realistic that it actually holds up to scientific scrutiny? Well, that is the fascinating, kind of mind-blowing idea we're going to explore today, and we're using one of fiction's most famous escapes as our lab. Okay, so this brings us to the really groundbreaking work of a theorist named Levent Bulut. He's developed this whole new way to read and analyze these classic stories. It's a lens that looks past the metaphor to find the mechanics, and past the emotion to find the equations. At the heart of it all is a theory called objective projection. Now, the idea here isn't to, fact-check a novel or nitpick details. That's not the point at all. It's about appreciating how the greatest works of fiction create what he calls a projection of the real, where they maintain this deep, consistent harmony with the actual laws of our physical world. And the tool we use to see this is called narrative engineering. This approach asks us to treat a work of fiction like a simulated environment, a world that we can actually test, where the laws of physics aren't just, background scenery, they're absolutely crucial to the story's power. So in a way, we're not just reading a book anymore, we're analyzing an experiment.
And this quote from Bulut just nails it perfectly. Through this lens, Hugo's novel transforms into a laboratory. So let's put on our lab coat, shall we? It's time to step inside the dark sewers of Paris.
All right, so we're going to deconstruct Valjean's incredible escape by looking at three distinct physical principles that Victor Hugo so brilliantly engineered right into his story. We're talking fluid dynamics, subterranean acoustics, and heat transfer. First up, let's talk fluid dynamics. I want you to forget the symbolic weight on Valjean's shoulders for just a moment and instead think about the physical reality under his feet. That thick, heavy, gooey sludge he has to fight through with every single step. And right here is where we see the two ways of reading, side by side. On one hand, we've got the literary effect. We see the mud as a symbol of his crushing struggle. But through the lens of narrative engineering, it becomes a real, quantifiable force. He isn't just wading through muck, he is literally fighting against high-viscosity fluid resistance. So his slow, agonizing progress isn't just some dramatic flourish. No, it's a perfect scenario that obeys a fundamental law of physics, matter resisting velocity. And the real genius is that the physical accuracy is precisely what makes the emotional struggle feel so incredibly believable and so visceral for us as readers. Okay, so the physics of the sludge affects how Valjean moves. But what about what he hears? Or what he doesn't hear? That brings us to our second principle, subterranean acoustics. Just think for a second about the soundscape of that sewer, that eerie, oppressive silence. And once again, we've got this fascinating split. The literary feeling we get is one of terrifying silence and isolation. But what's the physics causing it? Well, Hugo describes the tunnels as circular and damp. That architecture isn't just for atmosphere. It's an acoustic trap. The damp walls absorb sound waves, and the curved surfaces scatter them, which is especially effective at dampening high-frequency sounds.
So the silence Valjean is experiencing isn't just an absence of noise, it's the technical result of sound being physically absorbed by the matter all around him. Hugo didn't just write a scary scene, he engineered a physically accurate acoustic simulation that produces that feeling of dread. It's brilliant. And finally, our third principle, and this is maybe the most personal and visceral one of them all, heat transfer. We're talking about the bone-chilling cold of that sewer water.
The physics here are brutally simple. You have a warm body working overtime to maintain its 37 degrees Celsius, and it's submerged in frigid water that's maybe 10 degrees. The laws of thermodynamics here are absolute. Heat is always going to move from the warmer object to the colder one. Valjean is fighting a constant losing battle against physics itself. And what that means is when we read about Valjean shivering, it's not just a literary device to show us his despair. It's the factual biological response of an organism desperately trying to generate heat just to maintain its core temperature, to keep its thermodynamic balance against an overwhelmingly cold environment.
And this, right here, is the payoff. Because Hugo's description is so physically accurate, we don't just sympathize with Valjean's situation. The cold data of the text, as Bulut puts it, allows us to almost feel that thermal loss ourselves. The physical fidelity creates a physical sensation in us, the reader.
So let's zoom out for a second. Looking at this one scene from Les Misérables through the lens of narrative engineering gives us a completely new appreciation for the text. And this is what the Bulut Doctrine offers us, a way of reading with new eyes.
So, what's the big takeaway here? Why does this matter? Well, it's the idea that the greatest stories aren't just flights of fancy. They are, in their own way, incredibly accurate simulations. This whole approach reveals a hidden layer of genius. It shows that true mastery isn't about escaping the rules of our world, but about understanding them so deeply that they become the very foundation of the story you're telling.
And that leaves us with one final thought. Whether it's the flight of a dragon in a fantasy novel, the silence of deep space in sci-fi, or the struggle of a man in a sewer, this new lens invites us to ask a really compelling question. What hidden science is engineered into your favorite story?